already live. Twitch, let's do it like that. Yep, Twitch is already live. So now this should also, yes, everything is live. Good. Sorry, I'm 1 or 2 minutes late. I always plan these and like I need a few minutes to set up my drink situations, like the cappuccino and the tea. It takes usually a few moments, but I didn't want to push it another 5 minutes, and I like round numbers, so it's like, let's try to make it happen. And now I'm still a minute late, but yeah, no worries. Good evening, Luke. Welcome. I shall put on Spotify. Let me mute so that there's no feedback to the mic. I'll turn off my speakers, that is. So yeah, just getting everything ready here today. Okay, let's get this party started. I saw some things in the Discord already, and I heard from Luke that part 2 was a bit tough, so I'm very curious to see what today will hold, and if I will be able to do it, of course. So yeah, let's start reading day 17. Hey Nineberry, welcome. Loving the use of the emoji. I should probably add some more emojis to the chat. I only have one for each tier right now. I should probably mix that up or maybe create some more. But happy to see you use it. So yeah, let's see. Let's start reading day 17. Let's see what it's all about. Chronospatial computer. The historians push the button on their strange device, but this time you all just feel like you're falling. Situation critical, the device announces in a familiar voice. Bootstrapping process failed. Initializing debugger. The small handheld device suddenly unfolds into an entire computer. The historians look around nervously before one of them tosses it to you. Hot potato style. No. It's well written. You can clearly visualize what's happening. So, this seems to be a 3-bit computer. Its program is a list of 3-bit numbers, 0 to 7, like 0, 1, 2, 3. The computer also has 3 registers named A, B, and C, but these registers aren't limited to 3 bits and can instead hold any integer. Okay. The computer knows 8 instructions, each identified by a 3-bit number, called the instructions opcode. Each instruction also reads the 3-bit number after it as an input. It's called its operand. Okay. A number called the instruction pointer identifies the position in the program from which the number opcode will be read. It starts at 0, pointing at the first 3-bit number in the program, except for jump instructions, the instruction pointer increases by 2 after each instruction is processed. So this harkens back to int code, right? At least it gives that kind of vibes. To move past the instructions opcode and its operand. If the computer tries to read an opcode past the end of the program, it instead halts. Okay, so the program 0, 1, 2, 3 would run the instructions whose opcode is 0 and pass it to operand 1, and then run the instruction having opcode 2 and pass it to operand 3 and then halt. There are 2 types of operands. Each instruction specifies the type of its operand. The value of a literal operand is the operand itself. For example, the value of the literal operand 7 is the number 7. The value of a combo operand can be found as followed. Combo operands 0 to 3 represent literal values 0 to 3. Combo operand 4 represents the value of register A, 5 is B, 6 is C, and 7 is reserved and will not appear in any valid programs. Which is funny because here it says this. Let's see. Oh yeah, that's the, yeah, okay, never mind. I will have to go back and go through all the let's see. I will go back and go over it because there's already stuff mixing in my head. Let's see. The advanced instruction opcode 0 performs ADV. Okay, performs a division. The number is the value in the A register. Okay, so A division. Okay. The denominator is found by raising 2 to the power of the instructions combo operand. Okay. So the operand of 2 would divide A by 4. Okay. An operand of 5 would divide A by 2 to the power of B. Okay. Because that's a pointer to the register, sure. The result of the division operation is truncated to an integer and then written to the A register. Okay. There's a lot of stuff going on. And like truncated to an integer, do they mean a single digit number, or is it like a 32-bit or a 60-bit? Because integer doesn't specify the bit length by default. But I'll keep reading. The BXL instruction opcode 1 calculates the bitwise XOR of register B and the instruction's literal operand, then stores the result in register B. Okay, the BST instruction opcode 2 calls the value of its combo operand modulo 8 and thereby keeping it only. There's a lot of reading and instructions here. Jesus Christ. Thereby keeping only its lowest 3 bits and then write the value to the B register. The jump at 0 instruction does nothing if the A register is 0. However, if the A register is not 0, it jumps by setting the instruction pointer to the value of its literal operand. If this instruction jumps, the instruction pointer is not increased by 2 after the instruction. Okay. Let's see, Nineberry says part 1 is work, part 2 is fun. Okay. BXC instruction opcode 4 calculates the bitwise XOR of registers B and register C, then stores its result in register B. For legacy reasons, this instruction reads an operand but ignores it. Okay, the out instruction opcode 5 calculates the value of its combo operand modulo 8, then outputs that value. If a program outputs multiple values, they are separated by commas. The BDV, so B division instruction opcode 6 works exactly like the ADV instruction, except that the result is stored in the B register. The numerator is still read from the A register. Okay. The CDV instruction, same except in C. Here is an example of instruction operations. Jesus Christ. So yeah, there will be a lot of work to code all of this. This reads like a weekend problem, not a weekday problem. But I guess we're at a point where everything just becomes more complicated and more involved. Let's see. If C register contains 9, the program 2,6 would set register B to 1. If A register contains 10, the program blah 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 would output 0, 1, 2. If register A, yeah. Program blah 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 would output that and leave 0 in register A. Okay, these are a lot of examples. I still need to go back over it again to read it all, but fine. So these are examples, example instructions and states, and I will need to find a way to put this all into a test case, but yeah. The historian strings device has finished initializing its debugger and is displaying some information about the program it's trying to run, your puzzle input. For example, so there we have the registry values and the program. Your first task is to determine what the program is trying to output. To do this, initialize the registers to the given values, then run the given program, collecting any output produced by its instructions. Always join the values produced by out instructions with commas. After the above program halts, its final output will be this. Okay. Nineberry says, I took the encode computer from 2019 and modified it accordingly, but it's so different there was nothing left of the original source code afterwards. Yeah, I'll be going from scratch. It's okay. Using the information provided by the debugger, initialize the registers to the given values, then run the program. Once it halts, what do you get if you use commas to join the values? It outputs into a single string. Okay, so you put in a string here now. That's different. So yeah. Okay. Sure. Pooh. Interesting. Day 17. How long did you work on today's code? Let's see. So this is our test, and let's do it the new way that we've been doing it the last few days. Actually, I can join this at the front. So what I can do to parse the input is actually like input.toLines. It will trim out the empty one. Then I can do select x dot split by like this. Cost dot split. No, just comma as int reduce. Boom. So I can do, yeah, because this will give us a list of list. So I could actually do this like dot as value tuple 4. So we could have a list int a, b, c, d. So I could do a, b, c, d is this. And now I can have a record that does this. Luke says the fact that its input is so tiny should be a huge warning. Yeah, a lot of foreboding, I know. Let me think. Because I was doing this, I want to have. I also upgraded to .NET 9 so that I can do the local functions as well. By the way, I added that, so I can do y20 2024 day 17 parsed record. So we can have int we want to have this mutable probably, but I can have it just like I just do A, B, C. And then we have a list int opcodes instructions. So I can do static y parse string raw return new blah. So this will be A0 actually dot single. We can just do this so that we have an additional validation step as well. B dot single, C dot single, D. Nope. make that public. I always forget that. And when I make this public, it complains that this is not as accessible as the rest. So okay, parse input like this. Let's see, debug assert adds blah, 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 blah. Cleaning up failed for me after I tried everything. I tried everything collapsed. Yeah. Library says about 2 hours combined before work until I solved part 2. Then during work breaks and afterwards a bit cleanup. Yeah. I was afraid this was gonna be a long one. Boom, 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 boom. Actually, I can write it like this. Doesn't it like that? Yeah. Okay, that rewrites everything to support strings. Let me think. That was the easy part. Program day 17. So let's just do console.writeLine registers. So we can do parse A, B, instructions, string dot join comma. Okay, like this. So now if I run this, it should spit out the same. Oh. What is it trying to parse here? A backslash. Wait, what? That's interesting. Call stack. Let me set a breakpoint here to see what's happening, because this is interesting. This one should give 4 lines, it doesn't. Wait, did I have a quote too much? Oh yeah, I still had this one here. Never mind, okay. That explains why it broke. So this is parsed correctly, so at least that part is down. Now all the tough stuff, and I wonder if I still understand it, because it was like this. The registers, that was clear. Let's see. Operands, opcode, operand. So opcode, operand. Let's do that here. Hey Marte, welcome, and G, welcome. Let's see, G says, I've decided not to clean it up today and my code finished with an assert false. But finally a puzzle where the output is a string. Yeah. Welcome everybody. The thing is, I probably, because this is not writable, I probably need to turn this into a class where I do make this writable and changeable. So I should probably just make this a class. I wonder if this lets me do this. Looks like it. Nope. Okay. Let's just convert this so that we have writable stuff. Like this. This probably shouldn't all be public, but it's fine. Because you want this and then have all the logic in here. You probably don't even want to return this, but have like an this probably needs to be private. So you have your instructions. No, because you want to have returning at the end. But yeah, that's fine. Let me think. Probably not the first case that we should do. Case 4 return. I should actually make this like a switch, like you do return, operand, switch, and then like this. So you do 0 A 1. I know this is literal. 1 1. Then we do 4A, 5B, 6C, 7 becomes throw new not supported exception. We don't support operand. But this actually can be the default here. So that is our operand logic. I wonder if you can do a range here as well for 0 to 3. Probably. Luke says read again. Remember this for later when I'm stuck. I'll just keep going for now. Because it says 0 to 3 is literals, 4 is A, 5 is B, 6 is C, 7 will not be reserved. Yeah. Okay, let's go here. Then we have the 7 opcodes here. So we do void opcode. And we can do the same kind of thing here. Boom, 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 boom. Let me just write this out. Invalid opcode. Kind of want to define those. Just probably because I want to do it as a string later or at some point, or actually just let me code in text version and have the code work. Something like that. That's a reserved keyword, that's annoying. Let's see. Numerator and the A raising 2 to the power of the instructions combo operand. So if an operand of 2 would divide by 4, G says also, even if I complain a bit about it, Day 70 might be my favorite puzzle of this year. Yeah, stuff like this is fun. I just wish I had more ease of mind right now. But that is fine, and I probably need to do this not in a switch case because it will modify stuff, etc. So I'll just do it the old way: switch opcode. And I might even actually just implement it as functions. That might even be more fun. Yeah, that could be fun. You could do like void adv and have local functions here. But yeah, let's write every one of them out first, and then I'll see what I'll do with it. Boom, 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 boom. So we want to do Math.pow 2 comma, and then depending on we do operands like this. Is yeah, denominator found. Okay, this basically becomes a equals this, and then we do okay. And then there's truncation going on, so I'll have to check that as well, right? The result of division is truncated to integer. I still need to make sure that I know what they mean by that. Is this single digit or input to the max? I'll figure that out later. Let's see, a divided by that, operation yeah, okay. So I actually need to do like this. Sorry, that plus was from the cat. No worries. So a divided by this. To investigate later. So can I do, I wonder if it also works if there's no return value, so you could do like opcode switch 0 something like that. Probably not, right? Yeah, it's fine. Okay, bitwise XOR of B be stored in B. B is that just B this same here. I think I'll validate value to calculate the value of its combo operating modulo 8, thereby keeping its lowest 3 bits. Jesus Christ. So okay, BST, so void BST, and what did it do to B? Okay, it will be B is B modulo 8 and B like this. jump not 0, what was it again? If A is larger than 0, instruction pointer. Oh yeah, the instruction pointer always increases by 2. I need to do that as well. So we have could also do it by ref, but this is fine. Oh, so now I can still do the switch case and just make this return the pointer value. So now I can do like return pointer plus 2. So now I still can go back to return opcode switch blah. So then I can do 0 like this. Yay! I've changed this like 100 times already, so sorry for that. But this shrinks down the noise quite a bit. So. BXL, BST, GNZ. Okay. Does nothing. Actually, does that mean it also doesn't? It will always just include move the pointer forward, right? Is not increased by 2 after this operation. Okay. Okay. Return pointer plus 2. Otherwise, if was it A? Yeah. A is is 0 like this. Let's see. Jump is setting an instruction pointer to the value of its literal operand. Okay. Return operand. Like this. BXC. Calculates the bitwise XOR of register B and C, stores it in B. So B is BC, and then also just blah. For legacy reason, the instruction reads an operand but ignores it. Yeah, that's fine. It sounds like that might be a trap, but since reading does nothing yet, it's fine to ignore it. Calculates the value of its combo operand modulo 8. Then outputs that value. Then outputs that value. Ah, yeah, this is the output string. Okay. If a program outputs multiple values, they are separated by commas. So I need to have like list int output. Yeah, I can do it like this. It's fine. Combo operand. Okay. What did we call it? This was out. Okay. So we have int out. So now we have out add operand like this. We also move it forward. Was there anything else that I need to do? Oh no, it was modulo 8 this as well. Modulo 8. Works exactly like the ADV. Result in B and C. Okay. ADV. So this was BDV and CDV. Okay. Int BDV. Int CDV. So this is B and this is C. Okay. No. Like this. And I wonder if like 7 means like, okay, now put in the value of B and C into your instruction set or something, so that you chain a big thing out of it. That's something that I suspect for the later code. Let's see, 4 is 0, 1, 2, 3, 4, BXC. It's fine that the autocomplete knows better than me. This will be at out, except there it didn't. BDV, CDV. Okay, so now we have our computer. So now we can have a public string output, string.join output, like this. Then have a public string run. So this does int pointer is 0, while pointer larger equal to 0 and pointer smaller than instructions of count. Let's also do execution count is 0, max x. Let's set it to 100 million or something, 10 million for now. You know what? It's fine. Let's just assume that everything will be going swimmingly. So we do pointer is I could just call this execute instruction. Execute instruction pointer. Actually, it can just determine these things by itself. Boom. So we have this instructions pointer, instructions pointer plus 1. Okay, and these are ints, of course. I can make this an int so that it's just easier. Yes. And now I can do return output. So let's see if we have this. Sure. I can just, never mind, I can just do is parse.run, because in this case this is the out version. So let's see if this works. High hopes. I didn't check a lot of stuff, but oh yeah, this no longer works now because reasons. There is still 8 coming up. Boom. Object reference not set to an instance of an object because instructions is null. Wow. Wait, what? Didn't I do a parse? I had this double. G says, I understand, but I just like these virtual emulator stuff. Yeah. Library says there's still 8 coming up. Okay. About that this was the favorite puzzle this year. He meant so far. Okay, let me see. I need to do this differently. Actually, I need to make a constructor just so that this works. Public blah int a, something like that. Wow. Not output. This is fine. That isn't. And output is boom. What? This needs to be the constructor, right? No. Wait. The constructor declared in a type with parameter list must have this constructor in. Like this? Okay. Now it's properly initialized. Let's see what this does. Okay, was that the expected answer? Woohoo! False. Okay, what the? Why was it all zeros? That can't be the real input, right? That can't be the answer. I will need to check some stuff. Because there's no way that that is the answer. I'm gonna submit it just for shits and giggles, but... Okay. Okay, let's see. Boom, 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 boom. Read the part when I said read again. But why did this work for the test input? Yeah, okay. But what was that part? Let's see. What was the part that you wanted me to read again? Because I don't remember. Above the combo operands. This? 0 to 3 are present, literal values, I have that. ABC. 7 is reserved. Okay, let me check. There are 2 types of operands. Each instruction specifies the type of its operand. No, wait. The value of a literal operand is the operand itself. For example, the value of literal operand 7 is the number 7. The value of a combo operand can be as follows. I don't understand. Ah, wait, what? Okay, so BXL and G and Z needs to have the literal value. BXL and G and Z. Why doesn't the test case catch that? Thanks for that. BXL, G and Z. BXL. Wait, this is wait. The G and Z as one is weird. Because that means that the value can only, the jump can only be so small. So it would mean just operand this, and same for BXL. Let's see if I change the test to true, if it still works. Yes, okay. That's not the right answer, okay. Let me go back to reading. Was there more literals that I missed? No. Yeah, the literal operand is the operand itself. Literal 7 is 7. So if it's literal, it just means the value that's there, like 0 to 7. Yeah, I did that right. So that should be good. The only question is now why is the result wrong? The BXL extraction up to 1 and B and the operand and the returns is B. You also need to test it yourself whether all your commands are done correctly. The test example doesn't cover all of them. You didn't implement literal, but this is literal. See, opcode operand, that's just the literal value, So I no longer call it to this to evaluate, but I have the literal. So these are the literal values. Literal 5 return 5. Yes, that's what this does. This is the literal value. It's not being passed to the function to get it out. So I use the literal value here instead of calling it, pushing it to the operand function to get the indirect value. So these are literals. So that's, I've implemented that. Yeah, no worries. I know you mean well. So yeah, let's just set up these test cases then. Let's see. BST. It does modulo and then bitwise it truncates it. So like that's not even in the test case, so I need to do false. Oh, sure, yeah. Yeah, that's technically correct. I just literally did what it said without thinking what it actually does. So that is stupid. Also, probably B isn't the result. Did I read it wrong? BST. Well, it writes it to the B register. Oh no, it's it should be. I don't have the opcode stuff here. Damn. It should be this. Yeah. Kind of like this better. Yeah. I'll just do it like this. Is that correct? So let's see if that was the bug that I had. Woohoo! Thanks for that. Let's see what part 2 holds in store for us. So yeah, I forgot to run the BST against actually the operand, and I did it against itself. So that's just sloppy coding by me. Sorry for that. Woohoo! Large AOC stars. I love it. Let's see. So let's see what part 2 holds in store for us. Digging deeper in the device's manual, you discover the problem. This program is supposed to output another copy of the program. Unfortunately, the value in register A seems to have been corrupted. You'll need to find a new value to which you can initialize register A so that the program's output instruction produces an exact copy of the program itself. For example, this program outputs a copy of itself in register A's if register A is instead initialized to that. The original initial value of register A 2024 is ignored. What is the lowest positive initial value for register A that causes the program to output a copy of itself. Okay, so that means you have to work in reverse, I think. I should have the multiple test runner instead, but I think this is still fine if I run it like this. True. Yeah, so that produces its own copy. So, okay, that is fine. So yeah, that's the only thing that makes sense to me. You have to work backwards. So so now we need to do the inverse of everything. So let's say int reproduce list int instructions target. Okay, let's do that. This is interesting. Because basically we will need to do the inverse of this. Okay, like the output chair, the output thing is trying to think what if I can manually, if I hard code it myself here. Oh no, because it's also because we already know the program. I mean, you could probably brute force it step by step, just like no, because it's also Einbrace says part 2 sample uses a different program from part 1. Yeah, I know. I saw that. I'm just trying to think, like, my first idea was, okay, I have to go backwards. But the trick is, since it's dynamic, it can be really hard to produce this kind of sequence because there are jumps, etc. involved. So, yeah. I'm just thinking, can I code this in reverse? So if we just take this example, because this is a basic one, every one of these needs to get hit with an output statement, right? Every single digit requires to produce an output statement. And these are the instructions that we can execute. So we need to be able to flow through that given a certain input. So to output 0, we need actually the operand. Because you need to take the last two statements and from that jump make everything work. And I wonder if there's like an odd number here where you make it jump again. Like, what is a jump instruction? 3. Zero, 3, 5, 3, jump. Okay, so the last one is jump. Five is output. So it outputs this and then it jumps. Jump 0, literal, so don't interpret. So that's interesting because it is a 0 here, so that means don't jump and end the program. Let me think. Hey Sunco Software, welcome. Oh, I have the code off to the side. I'm sorry for that. Metalim says, no, it means different. What do you mean? No, it means different. Shift A write 3 bits, output next 3 bits, repeat. Was I reading it wrong? Yeah, 3-0 means it does nothing, right? Oh no, it jumps to the... No, wait. If A register is not 0... Oh, this is the A register. Oh yeah, it doesn't read the last... let's see. The instruction pointer... Wait. No, it's... Let's see. It does nothing if A register is 0. However, if it's not 0, it jumps by setting the instruction pointer to the value of its literal operand. And the literal operand is 0, so it would jump... Okay, while A is not 0, it will jump back to the start of the program. That's it. Yeah, my bad. It will start back to here and run this again. Okay. Sure. The logic for a 0 was division. Okay, so it divides the A. Sure. Damn. Trying to think. Because my first instinct was, okay, let's just do it in reverse. But now I'm trying to figure out how do I come up with what it needs to do there. Because the control flow is harder to control. And with like an exact example here, it's fine, but when you have the full thing, it's harder to tell. So you could just do like a queue algorithm and just skip out of it when it doesn't do the thing that you want, but that feels like the search space is so big. And the thing is, you can't change the program, just the input parameter. So it's really hard to figure out. Or is it? Yeah, because the jump flows, it's hard to know what it would take. Like this, in this simple example, it might be okay, but since this determines control flow over multiple iterations, it's really hard to come up with what the value should even be, I think. Or is it? Maybe I'm just thinking too hard here. Is there a way to efficiently cache all of that as well? The thing is, like the possible things that can happen at each stage isn't that different, but because these are wildcards, the whole state. How do I make this make sense? Let's see. Because I think the logic, the similar logic in the end is, okay, you just go to the back, so that it has the same kind of control structure there. So I should probably have translated this to like more like an assembly kind of style, so that you can read it easier. And I wondered if there was like a more fancy stuff going on where it would jump to like a non-even number so that you can then get even different combos of operators, etc., even though it's the same program. Nightmare says it's not so big and there's only that one jump. Yeah, I know, but I can just do it here. I could actually Let's make this more readable. Like this. BST. This. Okay. Basically, it's called like this. And the operand is always 0 here, so. Something like that. No, I'll just do it like this. DXC. Operand is not used. Okay. Like this. I could have done the same bit thing here. And this was just basically integer truncate, so not that it matters. EDV operand this, so B becomes Jesus, that's a lot. A divided by 2 to the power of that. And the same for C. Okay. So now if we run this, I should actually, after the so that just breaks out the loops. So let's see if we see a pattern here. So yeah, you can see 1, the 5, 0. So this is the output generator. It's all the same blocks of logic because there's no thing there, is there? Is it all the same flow here? I should probably also write out like ABC on every stage there, but no. I think it's the same thing every time. Okay. So I wonder if there's a way to find a relation between these that you can produce like output values. I'm sure there's a way, I'm just trying to figure it out. Because basically you know that if you have this state, it will produce a 5. If you have this state, it will produce a 3 and then a 5. But how do you come up with the other values? So what if you wanted to do this in reverse? So if you have like this and go in reverse, you go to this and then, so there's a way to do the math probably. So like I can end up with the character that I want here. How do you control the rest? Let's see the output. It takes just the operand. Let's see, what was the operand? 5, and 5 was it C? B? 5 must be B, right? 5 is B, okay. So if we work our way backwards, A must be 0 because we need to exit the loop. Right, so if you want to reconstruct this, A0 needs to exit after B5 last character we need to print. So the only thing that we can change for input is C here. So C is what controls everything that happens otherwise. C. So the interesting stuff would be like, okay, what if we find a way to work this in reverse? So we have BXL, which does modulo. Let's see, BXL. Literal. So it does B by the operand there, and the operand was 5, right? Okay, so it's modulo 5. So we do nothing there because it's fine, but B can be anything modulo 5, so it can also be a bigger value. So the BXL doesn't matter. Yeah, so the BXC is 1 to the power of 1, 0. Wait, what? BXC. Oh, yeah. That's a fun case where 1 to the power of 1 becomes 0. I've seen that before and it's so counterintuitive, but because I would say it's 1. Oh no, was it XOR? Never mind. BXC. The bitwise XOR. Never mind. But there's off. Why am I confusing stuff now? Because I remember like having something. Or was it 0 to the power? I don't remember. I'm mixing things up, trying to grasp at straws. Sorry. It's a bitwise XOR, so that is okay. So you just repeat that because the inverse of an XOR is also an XOR. So BXC, it takes, because C was 1 here. Does that matter? Why does it matter? Okay, so you BXC, what did it do? No, of B and C, wait, what? Bitwise of B and C. But B wasn't. Let's see. Okay, never mind. So B was 1, it gets turned into 0, and then turned into 5. Okay. Right, my whole thing of doing this in reverse is already tripping me up. I'm trying to think of how, if it's even feasible to do this in reverse. And I think kinda yeah, because we know that we have to end up with these values. A needs to be 0 and B needs to be 5, or at least modulo 8 of 5, so we can just keep incrementing that to try to control the other ones. A needs to be 0, that's 100%, so you have 2 variables to play with for your input here, that's B and C. So you could also make this 13 and then you get the same result, at least from that point of view, but you have to step backwards. So let's see. So if you would do this logic, I wonder if you could, if I could just write this in reverse, like the whole this. Execute reversed. Boom, 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 boom. The thing is, can you reason that? Yeah, because the control flow is fixed. No, I think I just need to hard code this in reverse to do it. Void one pass reverse pass. That's just let's see if I can even do this. Actually, and B and C. I think we can skip this one for now, because we know that it needs to be like a 0 step. We also need to have like int output expected, something like that. Now we can just, never mind. I can just run this and see what it does. So we can do int output is how did out work? It was B, right? I think 5 was B. Yes. Output is B. Then we need no, it's actually mod B. B. Like this. Then say is B say. Wait, no, B was this, right? B is that. BCL, let's see, BC, what was it, BCX? Yeah, BCL, then BCX, then ADIV, so this can be anything. This is a... this is like a destructive thing, so there's no way of going back here. I could try like every possible thing here. No. Okay, that's not gonna work for me. I just wonder if, like, because these three controls this and also how it loops again, I wonder if there's a way for me to cache some of this so that it can... These are very close to each other. Like, it's two more. This is two more. Check what happens when 8 and 64 and 5 12. Tiny hints. Yeah, but I'm not sure where to even plug it in. I'm not sure what you mean there. I mean, there is a clear relationship between this stuff, that's obvious. Like here, it's the difference again is like it's 2, and here it's 4. Here they are equal. Difference is 4 again. Difference is 2. Difference is 2. Difference is 1, 3. This divided by 2, is that same? No. But is this also divided by 2 again? 5a 7. I didn't do that properly. Okay. Not sure how relevant it is, but see. Restart the program with register A8, 64 and then 52. Okay, I can do that. My PC doesn't like that. Okay, is there something that's... Okay, need to be powers of 8 again. Wait. Okay, that's not it. I wonder though. So why does it do 7s and 6s? What's so special about 512? Because I expected maybe something with modulo 6, but really does 7 7 and then 6 is repeated, but that doesn't help me per se. I'm just thinking if there's like a bit pattern that triggers this, but how many digits is this? 2, 4, 6, 8, 10, 12, 14, 16. So this is like 2, 4, 6, 8, 10, 11. Okay. So this also needs to be not an int but a longs, because the values need to be way longer or way bigger. Bum, 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 bum. Let's see, debug print here as well. Bool print is false. Let's remove all of this for now. It's an interesting problem. Let's see if this gets me anywhere. Not with this. That should be fine now. Okay. This also means that I need to have my override different. Like this. Let's see, where is my okay. So this is 21, so this is longer than what we need because the answer or the input, let's see what we're looking for is this. So answer part 2 is not a const in this case. Answer P2 I actually can't get the instructions from here. That's interesting. Never mind. I'll hard code it for now. Answer from parsed input. So this, and then so at least I know how much, what the range is to get that many number of results, because it keeps dividing, so that will set a lower and an upper limit for the range that I have to brute force if I want to brute force it. G says 2 hour stream, I gotta go now, I may come back later, have fun. Yeah, thanks G. So yeah. Let me also add like a function here. I can just create a new one. No. Public y blah 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 clone. So this is A, B, C instructions. So this will give me a fresh copy to work on every time if I want to do this. So G says I have a long day on Wednesday and Thursday, so I might not be able to make it next week. Yeah, no worries. I'll see you when I see you. It's always nice to have you in chat. So let's try some logic here. So string result is long test value is how to and let's say answer b2 length as a start. Divided by 2 because we don't want the commas. String result is parsed clone run test value while result.length smaller than answer p2.length test value. Let's just do small steps because I think should also want to see this. Boom. So 17, 19, 21. Okay. This is 31. I still jumped over it. Never mind. So this is the test value where we can start. We can probably okay. Doesn't like it. So let's just go back there. Now I can do while result dot length lot smaller or equal than answer p2 dot length result not equal to answer p2 dot length like this. So this shall be horribly inefficient, but I'm curious to see if it works. Yeah, this is actually I should have just done this times 2 probably, and then I shouldn't have to do this. See, now it's fine. Nope. Should probably do like a midpoint finding here to divide the search space to where it goes over. this. Let's see. If result.length min is check, else if it's above, then max is check, check, this should have the search space every time. So let's see if my logic is correct. Let's add some watches here. Add watch, add watch, add watch. So result is lower. Yes, so we raise the min. Oh, and I then need to do this. So now result is still below, so we still raise the min. Still below. We're narrowing our search space every time. You're not changing max and min. Yes, I am. Min is check, max is check. Check is always the midpoint between min and max. So you can see the numbers change here. So now max. Yeah, no worries. This is basically a binary search. And it seems like the edge is very close to the max. So this gap, like the range, actually we do max, min. Like the range that we're checking is this. Can you see that on stream? I think so, right? So the search space is divided in half every time. See, now it's 2, and now the difference is 1. Boom. So now we know that if we're at this one, it will give, so long length min 1 is this, long exact length first value is this one. All right, so we can do string A is this, length min 1. And B becomes exact length first value, right? And I can do that here. So this one becomes min max. So let me just set it here and then I can show you. So A add watch dot length 29, B dot length, come on, also 29. Wait, let's run this again because this shouldn't happen. Let's see. Set next statement and we'll run it till here. Boom. Now it works. Okay, so now we know that we should start at this number and then brute force our way through. At least that's what we can do. So yeah. So now I can say best value is max. That min value is off by 1. Need to run some course? Nah, I think it might be okay. But let's keep like long brute force count is 0. If brute force count mod 100,000 is 0, console the right line. I mean, it does it fairly quickly. There's probably still lots that I can optimize. But I assume that the range can be quite big. At least it lets me skip a whole lot of... Actually, I could test to find what the max value is as well. And I should multi-thread this and oh yeah, the downside is for every character that's added, the search space becomes bigger. Let me think. Parallel 4, yeah. The thing is, my code isn't optimized at all. And I should probably also have a cache for anything that runs deeper. So basically, once I complete a run, I should probably, like, for each state Because basically you should be able to cache a whole lot as well. Because it divides down, there are certain ranges where they will hit the same exact values and you can just spit out all those steps. Dat was zo leuk. Nineberry says, even with parallelism, this will take hours. My answer is that how much higher than where you start, and I've seen another input that goes even a factor 10 higher than that. Okay, nice. These are like the amount of digits here. So this is let's see how many sets. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. I start at a value that's higher than a factor 10 higher than yours as well. That's where I start. But still, the amount of values that it might have to go through will be huge. So this plus 1 is where I'm starting. Have a look at that exact length number. It's a very special one. Yeah, I'm in the same boat. I also need to go to bed soon, so I might have to revisit this when I have some more time to play with this. But it's been a fun problem. So 1, 2, 3, 4, 5, 6, 7. So basically it's 2 to the power of, yeah. Was this 12 digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. What's the format for binary again? No. Bits string. I don't remember. Convert to string. Okay. What's the length of this one? Good morning. 64, and there were 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 16, I think. Amate says, lucky crunch time here, meaning no bad time today for me. I have to go to bed, but 10, 12, 16. Yeah, let's keep that one running. So this is all fun. Let's see. So what if I do let's do it like this. Wait, what if I created the permutations of each one of those? That would still be a lot. Okay, let's say that we do this. Okay, so interesting. If I set one in the middle, it will also do stuff there. Let's see if I had any messages. No. So roughly the place where you change those bits, logically that also changes the output there. Now I just wonder, is there a way that we can control a single number in a meaningful way? Let's see. So the first one created 7, 7. Wait. I got an idea. So these are basically like if I separate out just these 3 bits. Do I have control there? Let's see. So you have that one there. And it actually controls 2. So it gives us 77455622330011. Interesting. And it's funny that it didn't change anything else there. So what if I take this and I make another island here? What happens? I should probably count how many I do that too, but okay, that has a distorted effect, so maybe I need to be 1 over. Was I just lucky with this one? Or do I need to offset these to be stable? Let's see. Should probably make sure that I do it like this. So no, at first I just had these 2 columns, and now it has impact on more. Now I wonder if I need to I wonder if it becomes stable if I then add another one here. But maybe it was just a fluke. Interesting. So that gives a duplicate 6 and no 4, but I only change 1 character here. So what if I do another set of those? But the thing is, the numbers impact each other. So I wonder if I then need to offset that value. See, now these ones are different because it now affected the second row here. It's still funny that you can influence single rows right now, but there's a point where that changes because you go over stuff. Let me see, alright, if I do this, and I go back to 0, 0, 0, What if I make this 1, 0? Yeah. Let me first run this. Okay, so it does influence whatever comes next in a way. So would I need to encode the inverse there to keep it stable? So would this then be 1, 1, 0, 1, 0, 1, 1. Let's see. Oh wow. Look at that. When I do that, it shifts it over. So if I encode the inverse, it perfectly shifts that one over. You see that? 6, 7, 5, 6, 2, 3, 0. 6, 7, 5, 6, 2, 3, 0, 1. So I can have something and I can shift it over if I just inverse the next section. So basically, if I now would take like a bunch of zeros here, control that line. So let's say I take this block of zeros. I should probably make it multiples of 3. If I take that out and do it like this, should it then shift over those things entirely? 7, 5, 6, 2, 3, 0, 1. Yes. But it doesn't have the 6 one. Did I miss one? 2, 4, 6. I didn't copy a row apparently. Ah, I missed the... I only have 7 rows here, so I'm missing 1. Ah, 000, which doesn't matter. Yeah, never mind. So this, you should probably ignore just this first one. And then you can see that it works. So I have this one, I can shift it to the second row and I can also take it further. But then I don't have control over what happens after it, because that's just the sequence there. So that is funny. So I know how, if I make a perfect row, I know how to shift it over without... What is actually the output that we need? Was there a 4 in there? Yes. I don't know how to make 4s yet. So there is funny properties to all of this, but I'm just not so sure how to proceed. So I will end it here for today, I think, because it's getting late and I need to get some sleep and I have lots of stuff to do tomorrow. But I'll give it a good thing to see what I can do to make these numbers less magic. So yeah, I think we'll leave it here for now. Let's see if there's somebody that we can raid. Boom, 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 boom. Twitch. Advent of code. Catching up with the calendar. Sounds fun. Let's see. Oh. My PC is just freezing. I should stop that probably. Come on. Come on. Okay.
Although no, actually this is nicer because it's separating with the comma. So